Hello, and this is a video to accompany section 6.5 on the remainder theorem and the factor theorem. In the previous video, we looked at long division for real numbers and long division for polynomials. And now we're going to look at synthetic division for polynomials. So first off, synthetic division is a compact way of dividing polynomials when the divisor is a linear expression. What we cannot divide by is something like x squared plus 3. And that's when that's outside of the bracket. It's okay if it's something like x plus 3, that would be linear, but x squared plus 3 would not be linear, and therefore we cannot do synthetic division. Also, it's going to be very important that we align our terms properly. We'll see what that means momentarily. When we do that, the variables become unnecessary. So let's look at the example that we did with long division, which is the same problem, 2x cubed minus 3x squared minus 5x minus 12 divided by x minus 3. So first thing I'm going to notice is that I have a cubic as my degree. I have a squared for my next term. I have an x to the 1, and I have my constant. There are no terms missing between the x cubed and the 12. If I had any terms missing, for example, if I did not have this negative 5x, I would have to put a 0 in its place, a 0x to the 1. But I don't have that here, so this is going to be a nicer one. So I'm going to disregard all of these variables, and I'm just going to bring down the coefficients, including the signs. Negative 5x, negative 5, negative 12, negative 12. And what I'm going to do is I'm going to solve this x minus 3 equals 0. And when I do that, I get that x should be 3. So I'm going to put a 3 out here, and I'm just putting this bracket. That's really just for myself, but in putting that out there to signify that that's separate from these numbers that I have here. And I'm putting a bar down here with some space. I'm going to have some numbers that go in here, under all these numbers here, and I'm going to have a string of numbers that go across the bottom. And I really want to be able to keep track of all those because I'm going to use all those along the way. So here goes the procedure for synthetic division. The first thing I'm going to do is I'm going to add down. We always add down. That's our first step here. So I'm going to add 2 plus, well, there's nothing there. So 2 plus nothing, I'm just going to bring down that 2. So my first term I have down here is going to be a 2. The second step in our procedure is that I'm going to multiply in this fashion. This 3 times the 2, I multiply to get 6. I'm going to write that 6 up here. And then I'm going to add down. And I'm going to repeat this process until I get all the way down to the end over here. So again, I'm going to add down the negative 3 plus 6. I'm going to get 3. And I'm going to multiply again in this V formation. 3 times 3 gives me 9. I'm going to write that there. And I'm going to repeat add down, multiply in that V formation. Add down again. And I'm going to do that until I get to the end of my string of numbers. My last number happens to be 0. In either case, that is the remainder. I put this little dash bar there just to signify that that's my remainder. That's just for myself. But it is helpful for separating that out from the rest of the string of numbers, which, by the way, should look familiar from what we had before. We take these values here. The first number here after the bar, that's the constant. This is my coefficient for my linear term, my coefficient for my square term, and anything else I had after that would be my coefficients for my increasing degree. So the numbers here tell me that my solution is 2x squared plus 3x plus 4 with the remainder of 0. So that is the procedure for synthetic division. Please look to your book or your teacher for additional resources.